Hello, this is Saurabh Dwivedi and I welcome you at the Chanakya Pratyogita Academy, Muradabad. So friends, today we are going to take the classes on the syllabus of the UPSC, and in UPSC I am covering the topics from the geography, because geography is a very relevant subject in the entire syllabus of the UPSC. So we are going to take the classes related with the geographical aspect. The geographical aspect. So the topic for the discussion are the continental drift theory and plate tectonics. Plate tectonics theory. So one by one we'll see how the continental drift theory has been evolved, what are their pros and cons were there, what are the earlier theory, means before coming to this continental drift theory was there, then we'll discuss about the plate tectonic theory. And in between the plate tectonic theory, we'll discuss some more theories, some other theories. So why I am going to discuss some other theories? Because I am going to create an interlink in between continental drift theory and the plate tectonic theory, right? So now we'll start the chapter. The first we'll discuss about the continental drift theory. Continental drift theory. So before we discuss the chapter, we'll little bit talk about what is continent, what is the drift, what is the combination of continental drift theory. So first of all, the continent means if I'll make a globe of the earth, and in this globe, if you observe, this is the map . This is the map of the world. See? So these are the physical part which is known as the different continents. They are the continents first. So the basic is what is continent? Means the continent which in present form, whatever you are seeing, whatever you are observing in this entire earth, all the continents are known as the continents. Means all the surface is known as the continent. Like this is the North America, this is the South America, this is Africa, this is the Europe, this is the Eurasia, this is the India, and here is the Australia and New Zealand and the Antarctica. So these are the continents which you observed in present situation. But the concept is that, do you believe the exact location of all these continents are same in during the formation of Earth? This is the question, right? So whatever you are observing in this particular globe, these continents are the same in position which we compare this with during the formation of Earth. So that is the question, means that is the filler point has given the thought process, the continents exact positions during the formation of Earth. So see, next. When the Earth has been formed before 4.5 billion years ago, right? And this Earth formation take billions of years. So the exact condition which I shown you here is, I suppose, was different, may be different. So that is we are going to study. See, there is a concept which was given by the Hoffman. The concept Hoffman, he has given this concept in 1999, and what he tries to give you, he said, he talked about the supercontinent. The supercontinent. What is the supercontinent? The supercontinent, he said, that is a clustering of the entire continent. The clustering of continent. And in continent, he said that the Gondwana part is something different. Means he has just focused over the Gondwana land part. I'll explain you what is Gondwana land and what other terms are there. I'll explain you one by one. So first time he has given the concept that is supercontinent. This supercontinent, on what basis he had just given this concept, was based on 7 periods. It was based on 7 periods. Means the exact position, means the current position of the continents has undergone with the 7 periods. The first period was known as Ur. The first period was known as Ur. Second was known as Kenor land. The second one was known as Kenor land. The third one was known as Proto-Pangea. Proto-Pangea. The third one is known as Proto-Pangea. Next was the Columbia. Columbia. Ur, Kenor land, Proto-Pangea, Columbia. Next one is the Rodinia. Then the Pannotia. And last one is the Pangea. So first Ur, second Kenor land, third Proto-Pangea, fourth Columbia, fifth Rodinia, sixth Pannotia, and the seventh is the Pangea. This entire period, which has been calculated since the 3.6 billion year ago. So from that point of time, it has come across the 600 million year ago. It has come up to the 600 million year ago, and then the concept of Pangea evolved. And the time period is known as 200 million year ago. So this is the Pangea. So I'll explain you what is first what is Pangea. So this is the globe, and I'm making it. This is the globe. So the position of the entire continent, is known as Pangea. But this Pangea means the agglomeration of the continent has also passed from this entire period. Means this present situation of the continents is the latest one, and that is known as Pangea. Prior to the Pangea, there was the Pannotia. So if we see the continental position, in Pannotia, it looks like again something like this, something like this. This was the Pannotia. Means by the period of time, the fragmentation has been taken place. Means the split of continent. Continent means the supercontinent. Split of supercontinent has been done. So this is the entire phenomena which is follows since the formation of the earth. Now we'll discuss how this theory has evolved. See, there is a very big name behind this theory, Alfred Wegener. Very renowned name, that is Alfred Wegener. The Alfred Wegener has given this continental theory in 1909. And Alfred Wegener was the German meteorologist or climatologist. He was majorly the climatologist, and what he was trying to find out, there were two thoughts that time, whether the climate is dynamic and continents are stable. Second one was whether the climate is vice versa, means the stable and continent are dynamic. So what he thought, he went with this thought, the continent are dynamic. So this was the hypothesis which Wegener has adopted and then he carried forward. So this was the continents are dynamic. This was the basic hypothesis, this was the basic premise which has forced the Alfred Wegener to study about what is the position of the exact continents during the formation of the earth, means all the stages which we have earlier studied, it has undergone. So that time this categorization was not present, so he was just focused over the Pannotia and especially over the Pangea, because that time he was studying a system. System was that what he was studying. He was studies the Carboniferous era. He was studying the Carboniferous era. And in that Carboniferous era, he was studying how the glaciation has been taken place, in this upper Carboniferous era. So during the Carboniferous era, how the glaciation has been taken place, and this glaciation is, the evidence of this glaciation is being seen in this part of India. This is the part of India where it is visible. Right? So the glaciation was the main hypothesis which he was studied, but during this study he got something new, that climate is stable or continents are dynamic. Okay, so this was the premise. When he started his hypothesis to move forward, what he got? See, the Alfred Wegener, I told you he was a German meteorologist and a climatologist, and he given this hypothesis in 1909. But the problem is that the translation of this concept availed in English in 1922 or 24 suppose. Right? So the English when the English version came, when the 1924 the English version came, that time people came aware about what is the continental drift theory, right? Chaliye, let's move forward. Just a second. Prior to Alfred Wegener, few more thinkers were there, and very prominent thinker at that time was the Abraham Artelier. That time he was the most prominent thinker and he was known as the Abraham Artelius. What he has given? He has given his thought during 1600, during the 16th century, near around 1545 or something. I don't know. Don't bother it. So Abraham Artelius has given the concept that there is a presence of two America, presence of Africa, presence of Eurasia. What he had delivered that time, Abraham Artelius, that there are the presence of two Americas, presence of Africa, and the presence of Eurasia, right? So this concept was given by Abraham Artelius in 1596. See, okay. Now we'll move forward. After the Abraham Artelius, the second thinker was the Antonio Snyder. Second one was the Antonio Snyder. The Antonio Snyder has given the concept. What he did, he has prepared the map. He has prepared the map of the entire continents, map of the world. Later on, the Abby Taylor came, and Abby Taylor has talked about the third one was the F.B. Taylor. And from the point of view of Abby Taylor, the continental drift has evolved. Continental drift evolved. This continental drift, which was given by the F.B. Taylor, was the hypothesis behind this was the horizontal motion of the continent. The horizontal motion of continent. This was his basic hypothesis, and he moves on with the thoughts of the horizontal motion of continent. Next, by the thoughts of Antonio Snyder, first he took the hypothesis of the Abraham Artelius. Second, he took the concept from the Antonio Snyder, and then he took the concept from the Abby Taylor. The Alfred Wegener has evolved the continental drift theory. Means after studying the hypothesis of the Abraham Artelius, then Antonio Snyder, and then the Abby Taylor, he has given his own hypothesis that is known as the continental drift theory. I think you are able to relate this continental drift theory from the earlier period of the time. See, चलिए हम लोग आगे will move it forward. We'll move forward. What is the continental drift theory? The continental drift theory, which the Alfred Wegener has evolved, he talked about three periods. he talked about three period. The first period was Carboniferous, Upper Carboniferous. Second one was the Eocene, that is the Eocene phase, and third one was the Pleistocene. So these are three phases where the Alfred Wegener has focused. How he represented their continental graphs in the map, how it looked like. See, the first one was look like the first which he was trying to shown in their map was something like this. If I inverse it, it will okay, just wait a minute. I will make the perfect picture of it. See, I will make the perfect picture. See, like this. In second phase, he tries to deflect it. He tries to deflect like this. In next phase, he again splitted the entire. He splitted the entire continent. So by the time, by the phases of the upper Carboniferous, Eocene, and up to the Pleistocene, the continents started splitting. The continents started splitting. So the concept which was brought by the Wegener, he said that he said that, sorry for the disturbance. He said that the continental part are known as Pangaea. The water part are known as Panthalassa. The continental part he represented are denoted as Pangaea. Then he focused on the water part and he described it as a Panthalassa. So this was the first bifurcation, the continental part and the oceanic part. Next, what are the upper Carboniferous, what is the Eocene, what is the Pleistocene? These are the eras. I'll just make a relation with you. These are the some phases. These are the phases which has evolved. This is the pre-Paleozoic era, then the Paleozoic era, that is epoch it is known as, and the Paleozoic era, then the Mesozoic, then the Cenozoic, then the Neozoic. So these are the phases. See, after the pre-Paleozoic era, the epoch has started, and this Paleozoic era has been divided into certain parts that is known as Cambrian, that is Ordovician, that is Silurian, that is Devonian, then Carboniferous. Carboniferous, that is Permian. So these are the era. Next was the Mesozoic, and Mesozoic is are of three types, that is Triassic, Jurassic and Cretaceous. Triassic, Jurassic and Cretaceous. Then the Cenozoic, it further divided into several parts, that is PEOMP, Eocene, Oligocene, Miocene, Paleocene, Paleocene, and further the Neozoic has been divided into two parts, Pleistocene and the Holocene. Where we are living, the present situation is this. Holocene is the present situation. So in Neozoic era, here we are living. So just imagine from this point of time in 2024 to just move in your life cycle up to the 3.5 billion year ago. The earth formation has taken place in 4.5 billion year ago, but that time the earth was so hot and it was settling down. So from when we move ahead, so we are calculating it from 3.5 billion year ago, because I had mentioned you at the period of Ur, at the time of supercontinent. I just given you the example now. See Ur, 3.6 billion year ago, that is billion. So I am talking about this Ur period. So these are the phases, and what I am trying to quote here, I just discussed about this Carboniferous, Eocene and the Pleistocene. So see here the Carboniferous, then the Eocene and then the Pleistocene. So these are the three epoch, means the Paleozoic era. That from the Paleozoic era means epoch, it is the Carboniferous. Then from the Cenozoic means Eocene, and the Neozoic Pleistocene. So these are the three phases which Wegener has focused. Now we'll move forward. One more term which was coined by the Wegener, when the split has been taken place, when the split is being observed, these splits are known as Tethys. Those split, and in those splits the water body is known as Tethys, right? So three terms which was coined by the Alfred Wegener. First one was the Pangea, the continental part. Second one was the Panthalassa, which was the oceanic part, and third one was the Tethys Sea. The Tethys Sea is the when the continents got splitted, so in between the water body is known as the Tethys Sea, right? So these are the three points which was coined by the Alfred Wegener. So I suppose you are able to understand what has the Alfred Wegener has tries to give you, right? Now after the Pleistocene, the Holocene era has come. And this Holocene era is the modern time. And in modern time, when I started my class, I shown you the entire globe, and in that globe I had shown you the entire map of the world, which is we are living in present situation. So it means what? It means before to this present situation, there was something different. What the Alfred Wegener is trying to give you in the form of theory, he just tries to give you that in Pleistocene era, we were something different. Now, in Holocene era, we are something new. It means it is also, he has also given you some pictures for the future as well. Means he tries to give you the continental drift theory is not going to stop, it can move further. So this was the hypothesis which was given by the Alfred Wegener. So in Alfred Wegener, when he was trying to give you the entire concept, he focused some evidences. He focused over some evidence. Because if any of the theory is there and any basis of the evidence is not there, so how it will become the theory, right? So he has given the first theory that the matching of the continent. The matching of continent. The matching of continent, it is also known as jigsaw fit. Jigsaw fit. So first evidence he had propounded the matching of the continent, that is jigsaw fit. Second one was the rocks of same age, the rocks of same age across the continents, and especially he focused Brazil in South America and Africa near Guinea or Ghana coast. So this second one was his evidence. Further, he talked about some tillies. I'll explain you later on what is the tillile. Next, he focused over the placer deposits. Placer deposits. I'll talk you what is the placer deposit. And the next one, he has given the distribution of fossils. So these are the evidences which was propounded, which was given by the Alfred Wegener, and in their evidences he has talked about each and every evidence. At that time when he has given his theory, it was looking very relevant. And how it was looking very relevant, I'll just explain you. See, he has first talked about the matching of the continent. The matching of the continent. How the matching of the continent? See, I'm making the map of here. So who was trying to match this jigsaw fit to this portion? He was trying to match this to this particular shape of the Africa and the Brazil. The first was the evidence, which has little bit the perfection was there. Second one was the rock of the same age across the continent. So he found the rocks which are available in this particular it looks like this. What he has given the evidence for the rocks which are available in this part are having the similarity. The Appalachian which is found here and the same in the Britain and the Ireland, some Hercynian rocks. So they have the similarity. So he has tried to give the evidence to correlate it that the rocks which are found in the northern America and southern America are similar to the northern part of the Europe and the southern the part of the Africa. So in this way he correlated that some times ago, these continents were clubbed together, right? Third, the third one is the tillais. What is the tillai? Tillai is the glaciers, means glaciation. Actually, what Wegener was doing, Wegener was studying, this is the only, because I earlier told you, during the upper Carboniferous, he said that there was the glaciation period has occurred. So their evidence he found out. So he tries to give the example that this part, means the Gondwana land part or the Indian this part, once they were connected, so in the name of Gondwana, so that time he also tries to give the example that in some rocks there is the deposits of the tillais, means the deposits of the glaciation in these rocks. Are found, especially in India, some parts of Madagascar and the Africa, and some parts of the South America. One thing I'll just explain you. When he draws the film of picture of the continents during the phase of the 200 million years ago, he tries to give the upper part is known as the Laurasia. He further categorized the entire continent into two parts. The upper part is known as the Laurasia and the lower part was known as the Gondwana land. So the Gondwana land, what I explained you, the Gondwana land is these part, South American part, African part, including the Madagascar, then the Indian part, and from the Gondwana, when the parts, some parts are the Antarctica, right, and some parts which moves towards the like Australia. Okay. This is the Gondwana land. New Zealand is not from the Gondwana. This has been dejected from the Antarctica. The dejection of the New Zealand, which is from the Antarctica, not from the Gondwana land. Okay, means that is the part of the Gondwana. But later on, the dejection from the dejection of the New Zealand has specially taken from the the Antarctica, right? So this was the concept. Then he talked about the placer deposits. What is the placer deposits? The placer deposits are nothing but the veins of gold. The veins of gold. The veins of gold, he said that once the continents were jigsaw fit, that time this part was adjacent to this part, and the evidence of placer deposits in Ghana, means gold deposits or placer deposits are in Ghana, and their veins are found in Brazil. The veins are found in Brazil because it has erupted maybe in the form of magma, so it has accumulated in upper part of the earth's surface, and the winds which has come across from the earth's surface or beneath of the earth, the winds are found in the this part. So in this way Alfred Wegener has tried to give the evidence, and he tries to prove the evidence that my evidence are foolproof. Last one is the distribution of forces. When he was discussing about the distribution of forces, what he said, the many forces which are found in these parts, many forces of the flora and fauna are found in these areas. There is a very famous example he has quoted, the lemur. The lemurs. So he got the evidences of the lemurs, and he said earlier some lemurs used to live in these areas in Gondwana land. So this was the evidence which he brought as to explain his entire theory. Okay, so I just explained you what are the evidences. Now we'll discuss what are the force which he talked about, the force behind the drifting, the force behind drift, because this is the main point of the for the hypothesis. Because any of the drift, any of the change in the entire continental portion, it is not possible. It is not possible without the force. So he talked about two forces. The first one, he has given the force in the form of pole fleeing, and second one was the tidal force. The first one was the pole fleeing, and second one was the tidal. What is the pole fleeing? He said that the earth is rotating on its axis, So during the rotation of earth on its axis, the movement of continents, the movement of continent taken place towards equator. Means what? He was talking about the movement of continent taken place towards equator. Means what? Means when the Alfred Wegener was propounding his theory, he said that the southern pole was situated at the place of South America, which is present South America. The southern pole was at South America, and the northern pole was something around at Africa. So what he is trying to say, that the movement of continent taken place towards the equator. In this way, so somewhere equator was there, he said. But imagine, I'll talk about the criticism later on. So it was his first force. He said that pole fleeing force. The second one was the tidal force. And you know that tidal force means the force of the sun and moon. The sun and the moon. The force of the sun and the moon was responsible to give the drift to the entire continent. These were the two forces which was propounded by the Alfred Wegener. Okay. Next. So after the theory of the Wegener and what he has propounded is in the form of force, again it was criticized by the later thinkers, later meteorologists. So the criticism again, the criticism occurred. Criticism. The first criticism was, he said that, what he said in the form of evidence, he said that the continents were in jigsaw fit. So later thinkers said it is not possible at every point of places. So not possible, not suitable at every point, not suitable at every point. Second, he said that the majorly he was criticized for the tidal force. The tidal force. Just imagine the tides which are we are observing in this particular time. Just imagine, is it so much powerful that it can pull the continents? You know very well the maximum tides are occurred in this particular place, Bay of Fundy, right? That is a maximum tidal force which just given the drift the water, oceanic water. So will it be possible that the tidal force will pull the continents, right? So this was crossed by the latter thinkers, and it was found that no, it is not possible, because if the tidal force is the responsible force, then it must be 1000 times more, 1000 times more super forcible. 1000 times more it should be forcible to pull the continents, right? So again, he was criticized for this, evidence. Then he said, continent has been drifted, but continent has been drifted. So how the mountains has been, in the form of Rockies and Andes come across, right? If continents were drifted, just so how the Rockies and Andes has been formed, right? But for that, what he said, that Sial is floating over Sima. And again, I'll just explain you the concept. Sial is floating over Sima. He was, believer of this concept. There is something Sial, that is something Sima. What is the Sial and Sima? This is the Earth. If I cut this portion, if the this is the Earth. So this is the part is known as Sial. This is the part which is known as Sima. Sial is the upper crust, and the upper crust means the mountains, plateaus, plains, whichever you are in the form of topography you are looking at the Earth surface. This is the made up of the Sial. Sial means the silica and aluminium. What is the Sima? The Sima means silica plus magnesium, right? So this is the Sial and this is Sima, and he was believer that the aluminium is Sial and aluminium is lighter than the magnesium. So he thought that the Sial is moving over the Sima, So that is why the formation of the maybe mountains have happened and the drift of the continent has been taken place. So this was his basic assumption behind the this concept. So but later on further this concept was crossed by the meteorologist. Next, I explained you how the jigsaw fit was crossed by the later thinkers. The concept of Sial and Sima, which is floating and which has drifted the entire continent, was also crossed, and also the forces was also crossed. So in this way, lastly, the theory of the Alfred Wegener was totally rejected. Okay, so when the theory which was propounded by the Alfred Wegener was rejected, though this theory is very prominent if you are going to study the how the continent has been formed. It was him that has given the basis to start the study and further move how the exact theory has been evolved, and that is known as plate tectonic theory. But my dear friends, before coming to the plate tectonic theory, some other concepts, some other theories has also evolved. And in this theoretical part, it is known as the post-drift theory. Post-drift theory. What is the post-drift theory? The post-drift theory, which is first studied as a convective current theory. Convective current theory. The convective current theory. The second, which was studied as the mapping of ocean floor. Mapping of ocean floor. Third, sea floor spreading. The sea floor spreading, and then the fourth one was plate tectonic. Fourth one was plate tectonic. Means before we are going to study the plate tectonic theory, we have to undergone with all these theories which has erupted, which has evolved after the Alfred Wegener. Right? Now we'll study one by one. What is the convective current theory? Convective current theory. So convective current theory, before we enter into this theoretical part, we'll understand what is the convective current. What is the convective current? The convective current, for that I'll just give you the very basic example of your household. When we are warming a water, that time these are the water molecules. When we started warming this water, what will happen? The heat will start and due to the heating of this particular pot, this pot will start heating this layer one by one. Why I am making in this stage, I'll just explain you. Wait. When the heating will start, the water molecules will lighten up. When the heating will start, the water molecules will lighten up. Why it will be lighten up? Because it is getting the heat. Due to the heat, it started losing their weight due to the low pressure concept. When it start losing, then it will become light. So what will happen? The lower part of the water body, water particles will move forward. But when it will move forward, then what will happen? The just above water particles which were not receive any heat till now will be having high pressure. So what will happen? This will came down and it will move forward. This will came down and it will move forward. So this is the process which is going to be taken place in this particular pot. See, in this way. Again, in this way. So this is the water current which is moving vertically. The water current will move vertically and the circulation will form. This is known as the convective current. Right? The vertical motion of the water molecules will be known as the convective current. Why I am explaining this you? Just wait for a moment. Just wait. This is the earth surface. This is the earth surface. This is the oceanic belt. Oceanic bed. These oceanic bed are also having some, trenches, ridges, volcanoes, like this. Many structures are there in the, you will find in the oceans as well, as it seems in the upper atmosphere, or the surface, like this. So once you will start moving towards the earth surface, means in beneath the earth, what you will get, the in depth the temperature will increase. As we started moving beneath the earth, you will get temperature will increase. The increase of temperature also due to the increase of the pressure. Why the pressure will increase? Because beneath the earth there are various rock surface are available here. So due to the exerted force by the rocks, it will create the pressure. When there will be creation of the pressure, the friction will take place in between the rocks. Due to the friction, temperature will increase. First concept I think you have cleared. The exertion of the rocks will create the pressure. Due to the pressure, the friction will happen. The friction also creates the temperature, so temperature will be high. Second topic, these rocks are made up of minerals. These rocks are made up of minerals and various minerals which may be chemically active At the same time, the rocks may be of nuclearly active. That is Ca, that is Na. Means chemically active minerals and nuclearly active minerals. It means what? When you will go beneath the earth, you will find some nuclearly active elements as well. These nuclearly active minerals, just like uranium, I'm mentioning here, uranium, thorium, francium, protactinium, right? Polonium. These all are the nuclearly active elements. If there is a presence of these nuclear active elements, what will happen? These active elements will emit the energy, which you might have studied in the physics. The nuclearly active elements are emitting the energy. When they started emitting the energy, what will happen? They will increase the temperature in this particular earth surface, in this particular these layers, in this particular region of the earth, beneath the earth. So it will start increasing the temperature. So what will happen? The rocks which are chemically active, which are non-chemically active, which are soft, which are hard, whatever it may be, the nuclearly active material will melt them. What will happen? Whatever the nature of the minerals are available, these nuclearly active elements like uranium, thorium, francium, polonium, protactinium will melt them. When it will be melted, the entire rock surface will be melted, then it will look for some space to be erupted. Then it will start looking to move somewhere else. So in this way, it will started moving forward. It will started moving upward. Right? The same concept. When it start heating, the water molecule started moving upward, means vertical direction. So similarly, when the earth rocks will get heated, then it will start melting, and then it will start moving upward and vertically. So again I'm explaining you. What will happen? The layers, what will happen? These energy will circulate in this direction. So this is, they are forming the convective current, right? Convective current. Okay. So this was the process how the convective current brought the magma in upper layer. So this was the first concept which was given by the Alfred means post-drift theories, and this convective current theory was propounded by the Arthur Holmes. This theory was given by the Arthur Holmes nearly in around 1929. In between that, he has given this theory, convective current theory, and this convective current theory is very major topic for to understand how the mantle portion is in the magmatic form, how the magmatic form is erupting the magma over the earth surface. So these all concepts has been easily understand, right? So I just explain you how this process has occurred, right? So I'll just again just sum up the convective current theory, which I explained you with the basic example of the household. So in this way, the materials means the minerals are found chemically active, nuclearly active. These nuclearly active are also known as the radioactive. These are also known as the radioactive element, right? So these radioactive elements are pushing the continents in towards in this direction. So this is the process which was explained by the Arthur Holmes. Next, the next one was the mapping of ocean floor. The mapping of ocean floor, how it has evolved. Mapping of ocean floor. See, there was a means the people who they were studying the entire meteorological aspect, who they were studying the continental aspect and the spreading of the the drifting of the continents. They try to map the ocean floor. What they do? They try to map the ocean floor. And in ocean floor, especially they focus over the Atlantic Ocean. They focus over the Atlantic Ocean. In this way. So his focus of study was the entire this region. What he observed when he has mapped this entire ocean, the Atlantic Ocean, he got that this is the Atlantic Ocean. He observed that these are the ridges. These are the ridges. And these ridges are just 200 million years ago. These ridges has formed just before 200 million years ago. And they are the newest rock. And once they start moving towards in this direction, they got something. These rocks are little bit older. Means in between the Atlantic Ocean, they got the newer rock, and they moved from the newer rock, they got the older rocks. They also got that the seafloor having the mountains, having the trenches, having the guyots, having the atolls, having the volcanic eruption. So these structures which we used to see, which we observe over the continent, these all structures are also available in the in the oceanic floor. It means what? They have the again the continental drift may have been happened, because these structures, if they had formed, some basis behind the formation of the entire structure in this area, right? Next, the next one is sea floor spreading. Sea floor spreading. Sea floor spreading. What I just explained you in the second point, that is mapping of the sea floor, I'm just going to correlate the same concept in the sea floor spreading, right? Again, I'm going to make the earth surface and the oceanic surface. These oceanic surface are further, having the trenches, having the fjords, having the mountains, having the volcanoes, having the ridges, right? So these are the things which you will observe beneath the ocean. How the sea floors are spreading. The main the heading is the sea floor spreading. Means sea floors are spreading, means they are splitting. Means I just explained you the convective current. The convective current force is splitting this sea floor. Second, when the these plates are moving downwards, they are also erupting magma. Again the sea floor, the convective current. In this way they are moving in both the direction, means that is known as the drifting of the continents. So in sea floor spreading, that was propounded by Harry Hess. In 1961. In 1961, the Harry Hess propounded this sea floor spreading. So how he had proved their theory? The first he has given the example of the same, what I earlier explained you, the newest rock and the older rock. This was his first evidence in Atlantic Ocean. If you go beneath the Atlantic Ocean, the surface of Atlantic Ocean, in midway of the Atlantic Ocean, you will see that these rocks are the new rock. And I earlier explained you, these are the just 200 million years ago they had been formed. Once you move from this newer rock to the different direction, you will find that the nature of rocks will be older than this rock, right? So it is showing that the sea floor is spreading. It is showing that the sea floor is spreading in both the direction oppositely. But there is one important concept behind it, that neither means the earth shape, the shape of the earth is not increasing. The shape of the earth is not increasing, but here I am saying that the sea floor is spreading. It means what? It means once the sea floor is spreading, the new rocks is coming out in the form of magma. At the same time, the rocks are also destroying, right? Once the rocks are creating here, the creation is being taken place, at the same time destruction is also taking place. It means what? The equal amount of creation is equalize the equal amount of destruction. This is the basic concept behind the seafloor spreading. There are these few forces we'll talk in the next theory. So this was the Harry Hess, which was propounded in the name of the seafloor spreading. Right. Now we'll discuss another topic, the main topic which we are going to focus, the plate tectonic theory. I suppose you are able to understand what I have what was the post-drift theory. The post-drift theory, the convective current theory, then mapping of ocean floor has come, then the Harry has propounded the sea floor spreading, and now the now the plate tectonic theory has come, which I had given you in my initial lectures paradigm. So I'm writing here the plate tectonic theory. What is plate tectonic theory? And before we study the plate tectonic theory, what is plate? Right? Because we are going to study the plate tectonic. So first of all, we should know that what is plate. So the plate was the term which was coined by Tuzo Wilson. Right? The term plate was coined by Tuzo Wilson. Okay. Next, the term plate tectonic was coined by another thinker who was known as W.J. Morgan. W.J. Morgan. And the plate tectonic theory, when it came, some other thinkers like Mackenzie and Parker has talked about new global tectonic plate. Right? So in plate tectonic theory, the first term plate was coined by the Tuzo Wilson, and it was in 1965 around. It was in 1965. Then the plate tectonic term was coined. It was given by the W.J. Morgan, and it was in 1967. Right? So the term has been evolved in the name of plate tectonic. See, we'll move further. Why this theory plate tectonic has come? Why this theory has come? Because earlier theorist, means in the name of the Alfred Wegener, which we have already studied, he was later criticized by the other thinkers because the force which he has given was not appropriate. Later on, few other theories in the name of post-drift theories has come in the convective current theory, the mapping of the oceans, the seafloor spreading theory. So these theories have again came. So after the clubbing of all these theories, just listen to me, after the clubbing of all these previous theories, the new theory has evolved in the name of plate tectonic. New theory. So we can say clubbing of all previous theory. Clubbing of all previous theory is known as plate tectonic theory. Right? Why this theory has changed? See. Just a minute. Why this theory has come? I explained you the crust is creating and destroying at the same time. The crust is creating and destroying at the same time. Right? The second one was new crust is available. The new crust is creating. And the third one was the earth shape is constant, means no change of creation and destruction in their shape, right? In their shape. So that is why when this plate tectonic theory has come, that time it was felt that these questions must be resolved, and the Tuzo-Wilson has already said that the upper continental part this is the lithosphere, this is the asthenosphere, and these lithosphere and upper strata of asthenosphere, they are making the plate. They are making the plate. Means plates means what? The rocks means in the strata of rocks, right? So the upper portion of the earth which we used to observe are in the form of plates, and if you publish it like in the form of plate, then the earlier questions which were not resolved, it is all of a sudden resolved, right? How it has been resolved? Just imagine, if the entire earth, the surface is look like a plate, so it is going to solve the problem of how the Sial is the floating over the Sima, which was which was indicated by the Alfred Wegener. Then the concept has been changed into the lithosphere and asthenosphere. Then this lithosphere and asthenosphere is being observed as a plate. So this upper layer, the upper strata of the Earth's surface is known as the defined as the plates. So it will be easy to understand the plates are moving. Then it will make you to understand plates are moving. And once you got the concept how the plates are moving, it will resolve all the issues related to the formation of this particular present time of the Earth entire continental surface, right? So to explain this, this concept, there were, I'm just making a map of the world first of all. Sorry. So this is the map which I just tried to show you here. So why I just built this map? The entire plate system has been divided into major and minor plate system. Major and minor plate system. Major and minor plates. What are the major plates and what are the minor plates? In the entire world, it has been observed that there are 7 major plates are there. 7 major plates are there, and minor plates around 20 plates are there. So we are going to talk about the major plates first. The first plate was Antarctic plate. Second one was the North American plate. Third one was the South American plate, right? Third one, next one is the Pacific Ocean plate. Fifth one is the Eurasian plate. Next is the Indo-Australian New Zealand plate. And the seventh one is African plate. Right? So these are the 7 major plates: Antarctic plate, North American plate, South American plate, Pacific Ocean plate. It is also known as Pacific plate, Eurasian plate, Indo-Australian New Zealand plate, and the African plate. Right? These are the 7 major plates. Now we see where they are. Where they are. Here is the Antarctica. So first of all, the first plate which you have observed here, the Antarctic plate. This is the first plate, and how it looks in this way. This is the first plate. Next, the second plate is the North American. The third plate is South American plate. How it looks? This is the second, third. Fourth one is the Pacific. This is the fourth Pacific plate. The fifth one was the Eurasian plate. Fifth. The sixth one was the this Indian plate, Australian. It came in this way here. This is the sixth Indo-Australian New Zealand plate. Indo-Australian New Zealand plate. And the seventh one was the African plate. These are the 7 plates which are known as the major plates of the world when we study the plate tectonic theory. Now we'll talk about some other minor plates. The minor plates. The minor plates are first I'll mention few of the minor plates like Cocos, the Cocos plate, the Nazca plate, the Cocos plate, Nazca plate, then Arabian plate, next Philippines plate, Nazca, Cocos, Nazca, Arabian, Philippines, then the Caroline plate, next is the Fuji plate, few others are like Caribbean, right? So many of the Aleutian plate is also there. It is Aleutian plate. So many etc. I can say the plates are there. How their presence is there in the entire globe. I'll just show you the map. See. Here you will find Cocos plate. Here you will find Nazca. Then here you will see the Arabian plate. Then the Philippines plate. Here you will see the Caroline plate. near Japan, that is Fuji mountain. In this name of the Fuji, there is a Fuji plate. There is a Fuji plate. So Fuji plates is there. Any other remaining? All the has, I think I all have done. Aleutian you will hear. Few localized plates are also available in this entire globe. So the major plates are first Antarctica, then the North American plate, South American plate, third, fourth one is the African, Eurasian, Indo-Australian plate, Eurasian plate, African plate, the Pacific plate, right? So these are the major plates, and at the same time these blue pin which I mentioned here are the minor plates of the entire globe which are found. What is the major plates and minor plates? It means that the plates means their size of the plates. Their size of the plates makes them the major plates, and the size which are lower makes them the minor plate. So in this way, the major and minor plates are available in this entire globe, right? And these plates are moving. These plates are moving, and this movement, now we'll see the movement of plate. Movement of plate. The movement of plate is being tackled with the by three forces. First one is the divergent plate boundary. Divergent plate boundary. Second is the convergent plate boundary, and third one is the transverse plate boundary. How these plates act during the divergent, during the convergent, and during the transverse. See, when these plates will be diverging from each other, it will be known as divergent plate boundary. And when the plate will diverge, then what will happen? The magma will erupt, right? When the plates will be moving towards opposite directions, moving in the opposite direction, then it will be known as the divergent plate boundary. The second one is the convergent. When the plates are converging to each other, when the force will apply to each other, then what will happen? The convergent will take place. And in the convergent, what will happen? That some destruction will occur, and destruction here, construction, at the same time formation of mountains, right? The third, what will happen in third plate boundary? When the plates are just sliding to each other, then it is known as the transverse plate boundary, right? So these transverse plate boundary are responsible for earthquakes. They are responsible majorly for the earthquake over the continents. But divergent plate boundary and convergent plate boundary are very important to understand the plate tectonic theory. If you see this map, what is happening in this entire continental part? When these when these plates are moving, the Pacific plates are moving towards the North American plate and the South American plate, means there is a continent oceanic. These are the three plate collision. These are the three plate collision, means when the continent will collide, when the continent ocean will collide, and when the ocean will collide, then what will happen? See, here the Pacific plate is the oceanic plate and the North American plate is the continental plate. So here is the collision is OC, this one, OC, continent and ocean. Again explaining it, the Pacific plate is the oceanic plate, North American plate and the South American plate are the continental plate. So the collision is in between the oceanic plate and the continental plate, right? This continental collision has created the Rockies in this part and Andes in this part. I think you have got the concept. This collision of the Pacific and the North Atlantic in this particular part and in the South American plate, they are creating Rockies, and here they are creating Andes, right? Similarly, I'm giving you another example of this continent. I am giving the example of continent. The continent, if you observe this Indian plate, this is continent, and if you observe this continent plate, Eurasian plate, it is also continent. Means there will be the collision of continent. There will be the collision of continent. So what will happen when the continent is colliding with the continent? What will happen? It will form the mountain. And during the Eocene phase, which I earlier discussed about the geological cycle, if you are not able to recall, I am just going back. This Eocene phase, and during the from Carboniferous to this Eocene phase, if you see the drifting of India from Gondwana land taken place, and this drift of India has collided with Eurasian plate. This is the Indian and this is the Eurasian. So in this way, means when India was moving forward and this was the Eurasian plate, when it reaches up to the Eurasian plate, this vacuum part was filled with the Tethys Sea, and this Tethys Sea was filled in later period of time with the deposits which was brought by the rivers. So the entire region was filled with the deposit material, and when it hits the Eurasian plate, then what has happened? The formation of Greater Himalaya, the formation of Lesser Himalaya, and the formation of Shivalik has been taken place during the Eocene, Oligocene, and this was the phase when the formation of Himalaya has taken place. So this is the example of continent-continent collision. This is the concept behind continent-continent collision. Now, so I think you have to understand the entire concept. Next one is the oceanic. The oceanic, when the oceanic plate and oceanic plate, if they are colliding, then the formation, whatever the formation will be taking place, it will be in beneath the ocean. The formation of ridges, formation of mountains, trenches, atolls, and the formation of all the abyssal plains you will find in the ocean collision. There is another concept of ocean spreading as well. So that I had already discussed in the in Atlantic Ocean part, where the ocean and ocean are spreading. So due to the spreading, what will happen? The magma will comes out. The magma will comes out. So in this way, the ocean, if they are drifting, so it will happen. If they are colliding, then the formation of mountains, plateaus, and everything will be happening beneath the oceanic surface. So this is the concept which I explained you, and I just talked to you about what is the divergent plane and what is the convergent plane, and I also explained what is the transverse plate. The transverse plate are especially responsible for the earthquakes when the two plates they are just passing to each other. So that time the tremors are occurred. The tremors are occurred in the earth's surface, right? So this is the concept which I discussed here related to the formation of the major and minor plates. Then we'll talk about the movement of plates. What are the movement of plate? The divergent plate boundary, convergent plate boundary, and transverse plate boundaries are there. So for the force behind this, the concept was the thermal difference. The force, just mention the force. First one is the thermal force or say thermal difference. And the second one is the the thermal difference means when I was discussing about the minerals, means the rocks which have the minerals, and in some parts, and again just these are the rocks. These rocks having the radioactive materials, or minerals. These radioactive materials, they are melting the entire rock surface around the the neighboring rocks. So due to the melting, this portion will be having high temperature. But if we move forward, you will get the less temperature. So this is called the temperature difference, and this temperature difference brought the convective current. So that become the responsibility. This become the responsible for the movement of the plate, right? The second is the other geological activity. Other are the geological activity. Then what is the geological activity? The geological activities are not only confined with the convective current, but also the earth is moving on their own axis. It is also revolving towards the sun, and others are there, the pressure, temperature, all are the other factors are there who they are responsible for the movement of the plates. In that, how we can prove that the plates have moved, how we came across that plates are moved. So there should be some examples. So I'll just give you the example of that Arctic ridge. The Arctic ridge is moved. The Arctic ridge has moved 2 centimeter per year. The Arctic ridge which has moved 2 centimeter per year. Next is that there is a one island that is named as Easter Iceland. Easter Iceland. It is at the east of the Pacific Ocean. Easter Iceland. It is at the Pacific Ocean, and in the Eastern Pacific, and it is available at the south. If we I'll show you here. Here, in this particular part. In this particular part, the Easter Iceland. So this Easter Iceland are moving 15 centimeter per year. 15 centimeter per year. So in this way, we came across how the the plates are moving. If we are not able to give the example, then it means how we will prove it. So this is the concept which I just mentioned you here, and I suppose that you have came across the entire concept, right? So force, I mentioned you the thermal force, and that thermal force is being derived by the radioactive elements. Some other forces like in geological activities like heat is also there, due to the heat has found just because of the pressure is increasing in beneath the earth. So these are the some forces. And one more important geological activities force is that the residual force, or said the residual heat. Some residual heats are also available in the Earth's surface. So that become the means they creating the responsibility so for the movement of the plate. But further, every theory has some objections. Every theory has some objections. So again, this theory have objection, the criticism, right? Because every time you should having the welcome the criticism, so we can we can think for the something new. So when we discuss about the objections of the plate tectonic theory, or say the criticism of the plate tectonic theory, was the first point, which was just I'm noting down. The first point which was objected, that was the length of spreading ridge. The length of spreading ridge. The length of spreading ridge is far greater. The length of spreading ridge is far greater than the subduction zone. Means the ridge which are spreading is far greater than the subduction zones. Whatever the subducting part is taken place is lesser, more means the spreading of ridge is more. You will see in the oceanic surface. Second is the like one of the very good example for the plate when we discuss about the objections of the plate tectonic theory, or say the criticism, the formation of eastern mountains over Australia means the if you see the Australia, here the presence of the mountains, that is right. So how this mountain has been formed in the eastern part of Australia, right? If you observe, most of the mountains when we discussed about the Rockies, Andes, Alps, and the formation of the Himalayas, they all have been proved by the plate tectonic theory, but still the presence of the eastern Australian highlands, it is still not proved by the plate tectonic theory. So again, it is a criticism. The next is that the plate tectonic is also not able to explain that why the subduction is concentrated to only Pacific Ocean. Why the subduction is concentrated over the only Pacific Ocean? And this is the very basic question, is not means this plate tectonic theory is not able to give the answer. So I hope I just explained you the entire theory of what is the continental drift theory, and I just after that we have just tried to link the plate tectonic theory with the post drift theory. And in post drift theory we had talked about the convective current theory, then the mapping of the sea floor, then we talked about the sea floor spreading, and then we came across with the plate tectonic theory. So with the objections, and with the criticism, we came across that there is something which is missing by the plate tectonic theory. So again, I can say there is a hope for the future students who they can study well it, and they can give the answers which was not able to give by the plate tectonic theory. So for that, I thank you very much. Okay, so I had explained you everything.